We're from Group 7 and our members consist of Daniel, Nisa, Regine and Yuvan. Today, we're going to talk about an experiment which is related to sedimentation studies. There are 4 layers in the cylinder. A represents the clear liquid, B represents the constant composition zone, C represents the zone of variable composition, and D represents the sediment, where the particles settle below at the bottom of the cylinder. Sedimentation, also known as clarification, is the process of letting suspended material settle by gravity. Suspended material may be particles such as clay and slits, originally present in the source water. Sedimentation process is being widely used in various sectors, especially in the industrial sector.
To show you the mechanism of sedimentation. So, first of all, the effluent inlet enters here and fills up the sedimentation tank. Then, the solids will go down through gravity. The solids will then go to the scrapers, and these scrapers will help move the solids to the middle, where the solids will go out through here. The water will then go out from both sides. Sometimes we add coagulants to ease the sedimentation process.
This diagram shows the application of sedimentation. Firstly is the grit removal. It is settling of the sand, grave and other heavy solid. It protects the pump, reduce the formation of deposit in the pipe and remove inert material. In the primary sedimentation, we use the primary clarifier to remove suspended solids and settleable organic material. It decreases the loads of organic material that needs to be processed in the aeration tank. Moving on the secondary sedimentation, that contains the secondary clarifier, which is following aeration tank. The sedimentation of the biomass is to produce an effluent with a low solids concentration. Lastly is the sludge thickening, which performed on the biomass that is wasted from the aeration tank to further separate water from the biomass. It is to produce a highly concentrated stream of the wasted biomass and reduce the size requirement for the anaerobic digester.
Everyone, we are from Group 7. Our experiment today is about sedimentation. So in this experiment we have 2 parts. The first part is settling rate for different initial height and concentration. The second part is settling rate for different volume of fluctuants. For experiment A, the objective of experiment A is to study the effect of different heights and concentration on the settling rate, while the objective for experiment B is to study the different volume of fluctuants on the settling rate.
So before we start the experiment, we have to prepare 5 different sets of corn flour solutions in 5 different cylinders. For the first cylinder, we weigh 50 grams of corn flour and then 100 grams, 50, 100 and 100 grams. And then we add 2 liters of water using this measuring spoon. For the second part of the experiment, we repeat the same measurements, but this time we add a flocculant, which is aluminium oxide, and the measurement is 10 grams in 500 milliliter of water.
Okay, so once you have your solutions, you pour into these tubes. For the first two tubes, you pour until 90 cm. Then you pour for 60 cm, and then the next one you pour for 30 cm. But before you pour, make sure you pour half, and then you stir the mixture. Then you pour the rest. Okay. Then, for 5 minutes interval, some of the liquid will sedimentate. So you measure the clear height of the liquid. This is for 50 minutes.
As what we can conclude from this experiment, this sedimentation experiment is used in the wastewater industry.